Hello and welcome to Algebra 2 Lesson 18. In this video, we're going to continue to learn about slope. So in our last lesson, we talked all about how to find the slope of a line. And we learned the slope formula, which was m, which denotes slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we learned this formula. So if I had an equation, for example, like this one, 2x plus y equals 4, I could find 2 points. I could plug those 2 points into this formula, and I could calculate a slope. So let's do that real fast. So for this one, 2 points, if I choose 0 for x, my y-intercept, I would have 0 times 2, so this would go away. I just have y equals 4. If I chose 0 for y, I would have 2x is equal to 4. I would divide both sides by 2, and I would get x equals 2. So the x-intercept occurs when y is 0 and x is 2. So I have 2 points there. Once I have my 2 points, I label them. So they're ordered pairs. One is 0, 4. The other is 2, 0. So again, it doesn't matter which I label as which. I'm going to label this one as x sub 1, y sub 1, and this one as x sub 2, y sub 2. You could switch that around, and you're going to get the same answer. So I plug into this formula. I have m is equal to, for y sub 2, I have 0, minus for y sub 1, I have 4. And this is over. For x sub 2, I have 2, minus for x sub 1, I have 0. So 0 minus 4 is negative 4. 2 minus 0 is 2. Negative 4 over 2 is negative 2. So my slope m is negative 2. So we're going to talk more about what that means in a second, but I want to show you something else. We talked about this in the lesson also. The quicker way to kind of get the slope is to solve the equation for y. We put it into a format that is known as slope-intercept form. So let me just note that m is equal to negative 2 here. So slope-intercept form looks like this. It's y equals m, which is your slope, times x plus b. So this is slope-intercept form. And if you haven't gotten to this in your class yet, you're going to cover this when you talk about different forms of the line, okay? But it's good to kind of get started with it now because it's just a quick and easy way to get the slope. So if I solve this for y, meaning I isolate y on one side of the equation by itself, I just subtract 2x away from each side. This will cancel. I'll have y is equal to negative 2x plus 4. Now again, it's y equals m, the slope, times x plus b. So y equals negative 2. Negative 2 is m. This is the slope. We found that over here by doing a more complex procedure. Right? We had to generate points. We had to label the points. We had to plug them in, so on and so forth. This is so much faster. All I got to do is solve for y and look at the coefficient for x. So it's kind of an upgraded procedure. So we solve the equation for y. We automatically know the slope. Now, the other thing we have is we have the y-intercept. Remember, to get the y-intercept, I plug in a 0 for x, and I find out what y is. Well, if I plug in a 0 for x, I'm always going to have this right here, right? Because 0 times m would give me 0. So this would cancel away, and I'd have a y-intercept that occurs at 0, b. That's why it's called slope-intercept form. We know the slope, and we know the y-intercept. All right, so for this particular one, I know that the y-intercept would occur at 0, 4. Now, what can I do with this information? Well, again, it allows us to know the slope very quickly. It allows us to know the y-intercept very quickly. But it also allows me to graph very, very quickly. I don't have to sit there and generate 3 points and then go plot the points and do all this work. I can simply take this point right here, 0, 4. I can go to my coordinate plane. And let me label this. This is the x-axis. This is the y-axis. So where's 0, 4? Well, that's going to be right here. Now, remember, my slope m is equal to negative 2. So what does that mean? We talked about that in the last lesson. We talked about rise over run. So rise over run here is negative 2 over 1. right? Because I could take -2 and just put it over 1. So I rise -2. That means I just fall. So I'm going to go down 2 units. I run 1. That means I go to the right 1. So when we talk about running, we're talking about horizontal movement. So if that's positive, I'm going to the right. If it's negative, I'm going to the left. When we talk about rising, if it's positive, I'm going up. If it's negative, I'm going down. So that's why -2 over 1, I went down 2 to the right 1. And just do that again. So down 2 to the right 1. And now I have 3 points here. Of course, I only need 2 to make a line, but it's nice to have 3. I'm going to go ahead and just draw my line. And this is the graph for the equation 2x plus y is equal to 4. Now look how fast I found the slope, look how fast I found the y-intercept, and look how fast I graphed this thing. You know, in the previous lessons, we sat there and we generated points, and we did all these complex procedures, or not really complex, just kind of tedious things. Now, if I just solve this equation for y, I can go to my coordinate plane and graph it in like 2 seconds, okay? So this is the fastest way to graph a linear equation in 2 variables. Just solve it for y, use the y-intercept as your first point, and then use your slope to generate 1 or 2 or even 3 more points so that you can sketch the graph. All right, let's take a look at another example. So let's say you saw 5x minus 4y equals -12, and I asked you to find the slope, find the y-intercept, and to graph it. Okay, it's a common example that you might see. So let's start out by solving this for y. So this is y here. We've got to get it by itself. So my first objective is to move this over here. And I do that by just subtracting 5x from both sides of the equation. So this would cancel itself out. I'd have -4y is equal to -12 minus 5x. Of course, I'm going to switch the order there. So I'm just going to write that as -5x minus 12. And now to get y by itself, all I need to do is divide both sides of the equation by -4. So I'm going to divide this side by -4, and I'm going to divide this side by -4, but I'm going to do it to where I split it up. So what I mean by that is I'm going to put -5x over -4, and then I'm going to space this out and put plus -12 over -4. So that's going to make it obvious what I need to simplify to here. This will cancel with this, and I have y. And this equals -5 over -4. Can't really do anything with that, but I'm going to write 5/4 because I know the negative over negative will be positive. So 5/4 x, and then -12 over -4, I can write that as 3. So plus 3. Now, what information do I have? Well, I have my slope. Remember, it's y equals m the slope times x plus b. So my slope is 5/4. M equals 5/4. Now b, again, if I think about the y-intercept, it occurs at 0, b. Well, b is 3, so the y-intercept will occur at 0, 3. So let's use this information to graph the equation. So again, we found that this was y equals 5/4 times x plus 3. Now my y-intercept occurs at 0, 3. So 0, 3. And again, slope m is 5/4. So where is 0, 3? Well, it's going to be right here. Now, for a slope of 5/4, again, you think about rise over run is equal to 5/4. And it's very, very easy to figure out what's going on here. If rise is 5, that means I just go up 5 units. So 1, 2, 3, 4, 5. Now, if run is 4, then I go to the right 4. 1, 2, 3, 4. That's a point right there. And you can check that by plugging it in. So that's an x value of 4, a y value of 8. So if I plugged in a 4 here, 5/4 times 4, you know the 4s would cancel. You'd have 5 plus 3, which is 8. So that works out mathematically. All right. So now that we see that, can I rise 5 and go to the right 4 using what I have here? No, I'd run off. So what I want to do is I want to use a little trick. And you'll probably have to do this depending on the scale of what you're using to create your graph. But 5/4, realize with fractions, I can write this as negative 5 over negative 4. Negative over negative is positive, so the value of that fraction is still positive. And I can use that trick to start here, and I can say, well, the rise is negative 5. So I'm going to go 1, 2, 3, 4, 5 down. The run is negative 4. So horizontally, a negative 4 means I'm going to the left. So go to the left 1, 2, 3, 4, and that's where I'd be. And if you start at this point, you can use this to get back to this. I'd go up 1, 2, 3, 4, 5, go to the right 1, 2, 3, 4. So you can go back and forth in how you do that. Okay, so if you have a positive value, you can go negative over negative to get another point if you need to do that. So now that we have 3 points here, let's go ahead and sketch our graph. Okay, and let me just label this. Originally, we had it as 5x minus 4y equals negative 12. You could also label it with y equals 5, 4 is x plus 3. It doesn't really matter. You're just saying, hey, this is the equation for this line that we just graphed. All right, so now that we understand how to kind of manipulate an equation, and we can now graph very quickly, we can now find slope very fast, let's talk about something that's going to come up usually in the next section. So I want to talk about parallel and perpendicular lines. So two non-vertical lines that have the same slope are parallel. So you'll know that they have the same slope if you solve each equation for y. You'll have the same slope, but a different y-intercept. Those are parallel lines. And I'll graph an example of that so you can see what that looks like. Now, two perpendicular lines, have slopes whose product is negative 1. So again, for that, you would just solve each equation for y. You'd look at the slopes, and you'd see if you multiply them together, if you get negative 1, those two lines are going to be perpendicular. So very, very easy topic overall. Okay, let's go ahead and take a look at the first problem. So we have 3x plus 5y equals negative 15, along with 6x plus 10y equals 70. So the smart way to attack this problem is to solve each equation for y. We want it in the format of y equals m the slope times x plus b the y-intercept. Again, I can't say this enough. This is called slope-intercept form. So when we solve this for y, we will know the slope of each equation. We can then look at those two slopes, and we can see if they're the same. If they're the same, we have parallel lines. If they're different, then we're going to check to see if the product of those two slopes would be negative 1. If that's the case, we have perpendicular lines. And in some cases, we're not going to have parallel lines or perpendicular lines. You'll see problems where they're just neither. All right, so let's solve the first one for y here. So 3x plus 5y equals negative 15. So 3x plus 5y equals negative 15. If I want to isolate y, then what I'm going to do is I'm going to start by subtracting 3x away from each side of the equation. So that's going to give me 5y is equal to negative 3x minus 15. Then I'm going to divide each side of the equation by 5. And what's that going to give me? Well, we know that this would cancel with this. So y is by itself. So y is equal to, I'll have negative 3/5 x. So negative 3/5 x. And then minus, we have 15 over 5, which is 3. So let's erase this. And I'm just going to drag this over here. Okay, let's take a look at this one now. So 6x plus 10y equals 70. So again, 6x plus 10y is equal to 70. To solve this guy for y, let me just highlight that. I'm going to subtract 6x away from each side of the equation. So that's going to give me 10y is equal to negative 6x plus 70. I want y by itself, so let's divide both sides of the equation by 10. And I'll do that over here so there's room. So this cancels with this. Y is by itself, and it's equal to negative 6 over 10. Well, we know that they're both divisible by 2. So it's going to be negative. 6 divided by 2 is 3. 10 divided by 2 is 5. So this is negative 3/5. Then times x. Then plus. We have 70 over 10, which is just 7. So let's erase this. And let me drag this guy over here now. So we see that we have y equals negative 3/5 x minus 3 and y equals negative 3/5 x plus 7. So what can we conclude here? Well, we can see that the slope here is negative 3/5 and the slope here is also negative 3/5. So when two lines have the same slope and they have different y-intercepts, this one would have a y-intercept that occurs at 0, negative 3. This one would have a y-intercept that occurs at 0, 7. These two lines are parallel, right? They are parallel lines. Now let me make these e's a little better. What are parallel lines? Well, essentially, it looks something like this. And I know I didn't draw that perfectly, but parallel lines will have the same amount of distance between them no matter how far out you go. So you can imagine a coordinate plane, just stretch it in your head forever and ever and ever. These two lines have the same slope, the same steepness, so they have the same distance between them always. They're never, ever, ever going to intersect or touch each other in any way. So let's go ahead and take these two down to the coordinate plane. We're going to graph them, and we're going to take a look at what parallel lines would look like. All right, so for the first equation, y equals negative 3/5 x minus 3. The y-intercept occurs at 0, negative 3, so that's right here. And then the slope, again, rise over run, is equal to negative 3 over 5. So I can rise negative 3 and run 5, or I can rise 3 and run negative 5. Remember, negative over positive is the same as positive over negative. So again, these are little techniques you can use to get points depending on what the scale of your coordinate plane is. So I'm going to go with the negative 3 over 5. So I would go down 3, 1, 2, 3, to the right 5. 1, 2, 3, 4, 5. There's a point. Now let's say I want to make a point somewhere over here. So let's use this one out. Let's go up 3. 1, 2, 3. We're going to go to the left 5. 1, 2, 3, 4, 5. Okay, and again, this is y equals negative 3/5 x minus 3. Or, again, you could also write 3x plus 5, y equals negative 15. Whatever you want to write. All right, for the next one, we have y equals negative 3/5 x plus 7. So same slope, different y-intercept. Y-intercept there is at 0, 7. My slope is, again, negative 3/5. So again, I'm going to go down 1, 2, 3, to the right 1, 2, 3, 4, 5. And I'll just do that again. Let's go down 1, 2, 3, to the right 1, 2, 3, 4, 5. Okay, let's go ahead and graph this. Okay, and let me label this one as y equals negative 3/5 x plus 7. And again, you could write that as 6x plus 10y equals 70. It's the same thing in the end, right? One is solved for y, one is not. So now that we have this drawn, we can observe what parallel lines look like. There are two lines that will never ever intersect on the coordinate plane, right? These are parallel lines. And again, you can see that they have the same slope or the same steepness, okay? But they have different y-intercepts, so they're in different locations of the coordinate plane. And again, they're never, ever, ever going to touch because their slopes are the same. All right, let's take a look at the next example. So we have x plus 3y equals 12, and we have 4x minus 3y equals 3. So are these lines parallel? Are they perpendicular? Or are they just nothing? So I would solve each for y. Again, we're looking for y equals mx plus b. So for this one, I have x plus 3y equals 12. I subtract x away from each side. That'll cancel. I'll have 3y is equal to, let's switch the order here. I'll put negative x plus 12. And then I'll divide each side by 3. So this is going to cancel. I'll write y is equal to, I'm going to put a 1 there. So I put negative 1/3 x plus 12 over 3 is 4. Let's go ahead and write this. Erase everything here. So again, y is equal to negative 1/3 x plus 4. All right, for the next one, let's go ahead and do that over here. So 4x minus 3y is equal to 3. Let's subtract 4x away from each side. That's going to cancel. I'll have negative 3y is equal to negative 4x plus 3. And what I want to do now is I want to divide both sides by negative 3. This will cancel with this. I'll have y is equal to negative 4 over negative 3 is 4/3. And times x. And then 3 over negative 3 is negative 1. So minus 1. Let's erase all this. And let's write this here. So we have y equals 4/3 x minus 1. So looking at the slopes, what can we say? We have negative 1/3 and we have 4/3. So I know they're not the same. So they're not parallel lines. But would the product be negative 1? So if I took negative 1/3, which is the slope from here, and I multiplied it by 4/3, which is the slope from here, would that be equal to negative 1? Well, if I multiply here, negative 1 times 4 is negative 4. 3 times 3 is 9. So I end up with negative 4/9. So the answer to that is no. They're not parallel. They're not perpendicular. They're really neither. All right, let's take a look at one more. So we have 7x plus 4y equals 8. And we have negative 4x plus 7y equals negative 21. So again, I want to solve each for y. I want y equals mx plus b. So if I solve this guy for y, I would have, again, 7x plus 4y equals 8. Let's move 7x over to the other side. So subtract away from each side. This will cancel. I will have 4y is equal to negative 7x plus 8. Then let me divide each side by 4. So this will cancel. I'll have y is equal to negative 7/4 times x plus 8 over 4 is 2. Let's write what this is. Just drag this up here. All right, now let's go ahead and do this one now. So I have negative 4x plus 7y equals negative 21. And again, let me add 4x to each side of the equation. That's going to cancel. I'll have 7y is equal to 4x minus 21. I'll divide each side by 7. That'll cancel with that. I'll have y is equal to 4/7 x. Negative 21 over 7 is negative 3. So let me erase this. And I'll drag this up here. So y equals 4/7 x minus 3. So let's look at the slope in each case. This one, it's negative 7/4. This one, it's 4/7. Most of you can see that if I multiply those two together, I'm going to get negative 1, right? If I take negative 7/4 and I multiply it by 4/7, this cancels with this cancels with this, I'm just left with a negative 1. So if the product of the slopes is negative 1, we have something known as perpendicular lines. So perpendicular. And what this means is that these two lines will intersect at a 90-degree angle. For those of you who have never seen this or taken geometry before, I'm going to graph this real quick so that you can see it. All right, so let's take these two down to the coordinate plane. All right, so for this one, we have a y-intercept of 0, 2. So that's going to be right here. And then my slope, my rise over run, is negative 7/4. So if I start here and I rise negative 7, I go down 7 units. So 1, 2, 3, 4, 5, 6, 7. Then I run 4. So I go to the right 1, 2, 3, 4. So that's a point. Now I'd go off the coordinate plane that I have if I go down 7 and go to the right 4 again. So what I'm going to do, again, I'm going to use a trick. If I have negative 7 over 4, that's equal to 7 over negative 4. Okay? So I could start here and I could rise 7. 1, 2, 3, 4, 5, 6, 7. And I could run negative 4, which means I go to the left. 1, 2, 3, 4. So let me label this. This is y is equal to negative 7/4 x plus 2. All right, so for the other one, let me kind of erase this part because it's going to change. We have a y-intercept that occurs at 0, -3. So that is going to be right here. And then the next part is the slope is now 4/7. So let me change colors. For 4/7, I'm going to rise 4. So rise 1, 2, 3, 4. Go to the right 7. 1, 2, 3, 4, 5, 6, 7. It's right there. And again, I can reverse that. I can put 4/7 is equal to -4 over -7. Negative over negative is positive. So I could start here and I could go down 4, down 1, 2, 3, 4. And I could go to the left 7. 1, 2, 3, 4, 5, 6, 7. And again, this is going to be y is equal to 4/7 x minus 3. Now, I want you to look at something real quick. Again, if you've never seen a 90-degree angle or a right angle, as it's called, you want to look at the point of intersection here, which is right there. It forms a 90-degree angle, which is displayed with this symbol here. This is a 90-degree angle. And if there's one 90-degree angle, it's such that it's a 90-degree angle at all of them. So this is a 90-degree angle, this is a 90-degree angle, and this is a 90-degree angle. And you'll talk more about that in your geometry class. I mean, we really don't go way into this in algebra, but it's something you need to know to kind of understand what perpendicular lines are. It's, again, such that at the point of intersection, which is right here, you're going to form a 90-degree angle. And in fact, you're going to form 4 of them. So these are perpendicular lines.